This video is the second video on differentiation. In the previous video we found the gradient function. We call this process differentiation. We refer to the gradient function as a derivative. Remembering back what we did before, if we're differentiating a function of the form y equals ax to the n, where a is a constant, then we find the derivative dy by dx by multiplying by the power and reducing the power by 1. We'll start by considering the function y equals x cubed and look at the tangent at the point where x equals 1. We now consider the function 2x cubed. This function here, where the y values are double in each case, stretched by 2 in the y direction. You can see here that the tangent at x equals 1 has a gradient of 6. Multiplying y equals x cubed, our original function, by 2 has the effect of multiplying the gradient by 2. And this is always the case. Again, we haven't proved it, but we've shown it, and it will work in every case. So multiplying x to the n by a constant multiplies the gradient by that constant. We will look at proving this later on in the course. So if y equals 2x cubed, that implies that dy by dx equals 2 times 3x squared. In other words, 6x squared. Also apply the same principle if we're adding different terms. In other words, for sums and differences of terms. We can do them all independently. So for the first one, half x cubed becomes 3x squared for the x cubed times a half. 5x squared becomes 2x times 5. 7x just 7, or 7 times 1. And the 3, well, remember, if it's y equals minus 3, it's a horizontal line with a gradient of 0. So 0 for that one. If we then tidy it up, we end up with this. Okay, so to find the gradient at a point where x equals 1 on this curve, we differentiate to find the gradient function 9 and then drop the power 1. So 3 times 3, drop the power 1, gives us 9x squared. 2 times 2, drop the power 1, gives us 4x. Minus 1. We now put our x value of 1 in to give us our m value for the gradient of the tangent, and we get m equals 12. So the gradient at that point is 12, or the gradient of the tangent at that point is 12. So to summarise, the gradient at a point on a curve is defined as the gradient of the tangent at that point. The function that gives the gradient of a curve is called the gradient function. We differentiate to find it. The rule for differentiating, where we have y equals ax to the n, is dy by dx equals anx to the power of n minus 1. Power to the front and multiply, subtract 1 from the power. Okay, have a go at these, and like with the previous video, if you pause it, you can see the solution. So I'll put them up now. So for the first one, we get dy by dx is 6x squared minus 10x plus 7. And when x is 1, that gives us m equals 3. For the second one, 12x squared plus 6x minus 2. And when x is minus 1, we get m equals 4. And finally, dy by dx equals x minus 2. And when x equals 2, m equals 0.